I haven't yelled
Danny was in here.
I haven't yelled at any of my classes. Algebra 1, Thursday, the 6th of February.
Did you know it's Friday?
Is that how the calendar works?
Whoa!
Wait! Thursday? It does go to okay, anyway, so SWA, what's that stand for?
Students will be able
Students will be able to. Yeah, it is. Identify polynomials and their degrees. 6.4. Alright,
You know if I don't talk
So-
honestly.
terms. A blank is a number, variable, or a product of a number and one or more variables. This is a monomial. Yep. We'll talk about it.
Run through the word monogamous.
Anemone.
What?
Monogamous.
Okay.
That's what I know what you
Don't
meant.
even know the word.
You said it reminded you of it,
Okay.
and then you don't even know the word. Good job.
A monomial is a number, variable, or a product of a number and one or more variables. Okay? Mono, that prefix means what? One.
Disease.
Mono means one. Okay? So monomial is a one term. Okay?
What's a meal?
We talked about terms before. Okay? It goes nomial, but they just kind of combine it instead of mononomial. They call it monomial. Otherwise mononomial is like
Mononomial.
right? Like you get it? Yeah. Okay. But a nomial is just numerical terms. But so a nomial just means numerical terms. Okay. So I'm going to go through these blanks real quick, and then I'll do examples and non-examples that'll help us understand it. So monomials do not include denominators of a variable. Do not include denominators of a variable. So what that means is we don't have the variable in the bottom. There's no variable in the bottom.
Does this mean there's going to be fractions in a lot of them?
I literally just said there's no variables in the bottom of this one.
So no.
Yeah, no fractions.
Monomials do not include addition
There's not going to be fractions. Also, Dylan, does this mean there's going to be fractions?
or subtraction.
Hey, whoa. I feel the shade has been thrown.
It has. It's been observed. Okay. They do not include addition or subtraction.
Everybody been throwing shade at me today.
Monomials that are real numbers are
Thank you,
called
it's a little
constants. Monomials that are real numbers are called constants. That's not talking about real versus imaginary. It's talking about real numbers versus variables. Okay? Let me give some examples of a monomial.
Can't wait to
One,
tomorrow so I don't
three.
have to stay at home.
Is a monomial.
One.
One is also a monomial. Okay, three is a monomial.
Non-examples.
In this case, yeah, we'll get there. As a constant.
But there's a
Three.
fraction.
Did you say you were not going to talk?
Dylan. Stay
don't
where,
talk to
Dylan, look at me. Focus on where we're at in the notes. We'll get there in a moment. Okay? Don't freak out. What's ahead? Stay where we're at. Thank you. Examples. 3 is a type of monomial. It would be called a constant. It's just the number. There's one term, there's no addition or subtraction, and we don't have any denominators that are variables, no variables in the bottom. Here's another thing that would be a monomial. X squared y. X squared times y. And this one is a product, multiplication, of a number and one or more variables. In this case, it's more than one variable being multiplied together. But do we have any denominators? Do we see any variables in the bottom of a fraction? No. Do we have any addition or subtraction? No. And do we have, and so according to those two, it is perfectly still a monomial. It's called one term, even though we see two variables. Another example could be 1/2 x, y, z. It could be 1/2 x, y, z. You might be like, Mr. Gossel, what happened to this little fraction thing? Well, let's read that more carefully. They do not include denominators of a variable. Is there a variable in the bottom? No, it's a normal number. That's okay. 1/2 is a normal number. We just don't want the variable in the denominator for this to be a monomial. So 1/2 x times y times z is okay because we still do not include addition or subtraction. It's a number, a variable, so it could just be b, could be one as well. Number, a variable, or a product of one or more numbers and or variables. So non-examples. Non-examples, anyone know what that means?
Examples that don't work.
Yeah, the examples that don't work, right? Okay, these are not the ideal. Okay, A plus B. Can anyone tell me why that would be a non-example? Because we're adding. What's it say? What's the second part say?
There's no.
There's no addition or subtraction. Well, there's addition there. Boom, it's automatically not a monomial. Now, if I cover this up and I said A, is A a monomial? Yeah. Is B a monomial? But as soon as we add them, this together is not a monomial. The other one could be 1 over x squared. 1 over x squared. Dylan, tell me why this is not a monomial. There's a variable where? In the denominator. Very good. We had lots of variables over here in the examples, but here there's a variable in the denominator. That makes it a non-example. Questions on that? Okay. So determine if these are monomials. If you flip your page, we're going to determine if these are monomials. But I have the examples and non-examples still up here, so that way I can still utilize those. So 8f squared g. Do you think that's a monomial?
Yes.
Yes, I agree. There's no addition or subtraction. There's no variables in the bottom.
Yes, sir.
What about number 2, 17 minus s?
No, subtraction.
No, there's subtraction.
Also, there's nothing on number 3.
Let's even circle that so that way we know why it wasn't a monomial. Let's even circle that subtraction symbol or draw an arrow to it, just so we know, oh, that's why.
They printed wrong.
Okay? Yeah, it's different wrong. But what should it be?
3 over 4.
3 over 4.
Yes. Yes.
These fractions do not like to print well, do they?
And number 4 is no.
Okay? So wait. First of all, though, is 3/4 a monomial?
Slow
Yeah.
down.
Yes, it is.
Why are we going so fast?
Yes, it is because there's no denominator of a variable. The denominator is just 4, and there's no addition subtraction. What about 4? 5 over t?
No.
No. Why not?
Being divided by
Being divided by the
the variable.
variable. Variable's in the bottom. That makes it not a monomial. Questions over that? Right. So now we talk about monomials. We're going to talk about right below this. It's going to be called a polynomial. We're going to be called a polynomial. A polynomial is a monomial or a sum of monomials. It's either a monomial or a sum of monomials. Poly, does anyone know what that prefix means? Several, many, okay? Several, many. It literally means many, okay? There's multiples of them, okay? Or at least there can be. So it's either a monomial or a sum of monomials. So then we have different types of them that get a little more specific. So a blank is the sum or difference of 2 monomials. So if we have 2 monomials together, it's a polynomial, but more specifically, it's called a binomial. Then you'll know why we call it a binomial.
2.
Because bi means 2, right? Bicycle, okay? Bilingual, okay, 2 languages. Okay? What do we think we'll call the sum or difference of 3 monomials? Trinomial, very good. What if I just like randomly have like another name for it, and you're like, wrong, not a trinomial. Would that be rude? Yeah. Surprise, it's a quadnomial. Okay, so there's no such thing as a quadnomial, okay, or a quinnomial. We don't have special names for them if they're more than 3. We just have special names for 1, 2, and 3. After that, we just call it a 4-term polynomial, a 5-term polynomial. So polynomials with more than 3 terms do not have special names. There's called a 4-term, a 5-term, a 6-term, 7. We just name it by however many terms you have. But for these monomial, binomial, trinomial, we see those so commonly that we just have a name for them. So here's some examples of monomials: 7x, 4x, y to the third, z squared. Here's an example of a binomial: 3 plus 4a. Why is this not a monomial? There's addition. But is 3 a monomial? Is 4a a monomial? And a polynomial is a sum of monomials, or a monomial. So here we're adding 2 monomials, So now this is a polynomial, it's called a binomial. On the bottom, 7CDE plus CD squared. Once again, 7CDE is a monomial, CD squared is a monomial. Add them together, now it's no longer a monomial, but it rather is two, so it's a binomial, or a two-term polynomial, a binomial. Trinomial, the sum or subtraction, sum or difference, of three monomials, a, b, and c, or 3x squared, 2y, xy squared. Questions on those and why those are polynomials. Okay. Now we truly do consider a monomial to also be a polynomial. We consider all of these to be polynomials, but specifically this is a monomial, and these two are not monomials.
So then why do we even call them
Because we use the word monomial to define polynomial. So we had to start somewhere. That's a really good question. So anyone who here in Italia said, hey, Mr. Costle, you're pretty awesome. I say, oh, thanks. I think you are too. Okay. And she's like, so aside from that, though, why do we even have a monomial? Why do we call it that? Well, because we have to have a building block, and we use that as a building block to get the polynomial. That's how we define it. Right, Dylan? Yeah. Okay, you want to pick your head up, please? Gotta pick your head up. I love it. Okay. So, state whether each expression is a polynomial. If it is, identify it as a monomial, binomial, or trinomial. Okay? So for it to be a polynomial, it has to be made up of multiple monomials or one monomial. So if it wouldn't be, so it has to be made up of a monomial or multiple monomials. And then if it is simplified as a monomial, binomial, or trinomial, and be sure to simplify first if possible. Okay? 3a minus 7bc. What do we think? Is that a polynomial?
Binomial.
Yes, it is, and then more specifically, it's a binomial. Very good. Because we have two terms. We have two terms. Now, what we call a term here, guys, you guys remember talking about like terms before? Okay, this is where this really comes into play. Okay? Because we call each of these a term. Whenever we see this separation by addition and subtraction, that means there's two terms there. So 3a is a term, 7bc is a term, and they're separated by that subtraction. On 2, what would we say?
That would be a trinomial.
Why do you say that?
Because there's three addition signs.
Okay, well there's
Not
one.
even three signs that are changing.
Okay, well there's one sign here, and it was a binomial. Dalton.
It has four, doesn't it?
Okay, so you're saying it's a 4-term polynomial. So you think
Yeah,
it's a polynomial, but it's a 4-term. Okay, I agree. Yes, it's a polynomial. But I actually don't think it's a 4-term polynomial, even though we count 1, 2, 3, 4, because
there's like terms.
there's like terms. What like term do we have?
7, 8, and just
Awesome, 7, 8, and 8. Can we combine those? Yeah, so we really have 3x squared plus 8a minus 2. So this is actually what, Levi? It's actually a trinomial, not necessarily for the reason we thought earlier, but it is a trinomial. So yes, it is, but it's actually a trinomial. We want to simplify before we actually classify what it is. We want to simplify before we say, hey, this is what it is. Now, number 3, do we think this is a polynomial? Yes or no?
No, it's not. No, it's not.
Okay. You're being pretty vocal about this, Levi. What do you think?
There's a 2 R below.
We don't want this R here.
Oh, yeah.
So, for it to be a polynomial, each of these have to be a monomial. But is this one a monomial?
No.
No, because there's a variable on the bottom. Okay? No. So this one is not a polynomial. Questions on that? So it'd be very tempting to say, oh, it's a binomial. But be careful, because for it to be a polynomial, it has to be made up of monomials. And this 7 over 2r is not a monomial. Question on that? Gucci? Yes. Okay. Okay. So, what is a degree? Have you guys ever heard the term degree, like in math? Okay. Okay, you hear it with like angles, maybe like a 90-degree angle, like a corner. Okay. Otherwise, you hear probably degrees for like temperature. Okay. We also have degrees of polynomials, degrees of variable. Okay. So, the degree of a monomial, is the sum of exponents of all its variables. The degree of a monomial is the sum of exponents of all its variables. Does it say variables and constants? No, it just says variables. I even want you to underline that variables there, okay, please. Okay? Now sum, we wrote that word sum in there. What's sum mean?
Total.
Okay, total by addition. Okay, we're adding things up. Okay? The degree of a polynomial is the largest degree of any term in the polynomial. So for a monomial, we add up the exponents on the variables to find the degree. For a polynomial, we have to take each term and compare them to see which one has the biggest degree, and that's the degree of the whole polynomial. And we'll go through and practice this here. Find the degree of each monomial. What do we think the number one's going to be?
Largest.
Okay. Well, it's a monomial, right? So we're following this first one right now. It's the sum of the exponents of all its variables. So on number one, what variables do we see? Just y. What's y being raised to? The power of 3. So is there anything else to add to this 3? No, because we know they're variables. So the degree is just 3. What do we think it might be on 2?
2.
Okay, I heard 2. Okay, why do you say that? Why did we do second power? What's the a raised to? What's the b raised to? What do we have to do with all 4 of those? Add them. So what is the degree?
4 power.
It's 4. So don't just go with the largest in a monomial. We have to add all of the powers of the variables. So what do you think is going to be on 3? 0. We don't see any variables. We don't see any powers. Okay. 4 squared ABC.
3.
Power of 3. Very good. Because it's a to the first, b to the first, c to the first. Now we don't care if this is 4 squared. We only want the variables' powers. Does that make sense? Or no? Raise your hand if that doesn't make sense. Okay. Dylan. Awesome. Thank you for telling me. Okay. So, did number 1 make sense to you? Okay.
None of this.
Okay. What do you mean none of this does? Okay, none of the whole lesson has? Is that what you're saying? Okay. And we might need a reteaching moment a little bit later, okay? I'm not saying that's a bad thing. I'm just saying, like, oh, we need that. If you've lost that whole time, that's a lot to go back on right now. Okay, so we're going to have to go back on that a bit, okay? Let's try our best to follow along from now on, though. Okay, and see if we can at least get some of this later stuff right now, okay? Does that sound good? Can you do that for me? Okay, can you pick your head up? Okay, thank you. Okay. Part of that's also staying engaged, right? Okay. So, now we're going to find the degree of each polynomial. You said for a polynomial, it's the largest degree of any term in the polynomial. So here there's 2 terms in this polynomial. So the degree of this would be the largest term amongst these 2. So in order to know which one's the largest, we have to find the degree of each of them, right? So what's the degree of this first one?
9x squared. Well, no, the degree is 2.
The degree is 2 because the exponent has a power of 2. It's the only exponent. Nectaria, what's the degree of this 2x? 1. Okay? Now we don't add them together because for a polynomial, we just take the largest of these. So Presley, which one is larger? 2. So the degree of this polynomial is 2. We just go based on the largest one. Bless you, let's write down F, let's forget. So let's work on this second one here. I want you guys to actually try that. I want you guys to try that. Once you have it or have questions, raise your hand. Okay, go ahead and go on to number 3 there. Very good. So on this, the largest degree on the second one was 3. So that's the degree of the polynomial. It's the largest, so that's the degree of the polynomial. Okay, Dylan, what did you get from the last one? 4, very good. The largest degree on this one is 4. Okay, so that 4x to the 4. Questions on those guys? Okay, let's look at our last 3 examples for today. We're almost there. Yeah, this is the short lesson. Okay, we even took that time out to do the math kind of course tree, and we're almost done already. So we're going to rewrite each polynomial in standard form. We don't know what that means yet. Okay, you guys remember how like all year I've been kind of saying, well, actually we'd order it this way. Actually we'd order it this way with variables. This is the actual y. We're going to learn the actual y and what that is. Okay, I kept saying, hey, we'll learn that. We'll learn that. We'll learn that. Hey, we're learning that now. Okay. So what standard form means, and I want you guys to write this too. I want you guys to write this, is that we want it in descending order, and we also want it alphabetical. So we want it descending order, and we want it alphabetical. Now we would first look to put it alphabetical by variable. So if we see an A and an X, we'd want to put the A's first. But then we also want to go with descending order, to where we put the highest power first of a variable, of that alphabetical variable. So, in this one in standard form, 18x squared minus 91x to the third plus 30. Is there anything to sort out alphabetically here? No, because they're both x's. The other one doesn't have any. So now we just need it in descending order. So which one, so descending means from what to what? Greatest least. Descending means you're going down. So you have to start high to go down, right? Okay. Whereas if you're ascending, you're going up. So you're starting down and you're going up. But we're descending, we're starting top, and we're going down. So which one of these would go first? We go in descending order of our exponents. Okay? It'd be the negative 91x to the third. That would go first. We have to make sure we carry the negative with it. Then what would follow? 18x squared. And what kind of 18x squared is this? Positive or negative? Positive. So it's plus 18x squared. And then what comes last?
30.
Plus 30. That would be in our standard form. That's what we call standard form.
So if it doesn't have a variable, what's happening?
Yep, because that variable, because it technically has one, we could say. But what we would say, guys, is the variable it has is like 30 times x to the power of 0. Because what would x to the power of 0 really be? 1. So it's like 30 times 1, which is the same thing as 30. So we'd really say it technically has a variable, like air quote variable has a variable, but it's a power of 0. And so 0 would go after 3 and 2. But yeah, so if it doesn't have a variable, it goes at the end. Is basically a good way to think of it. Yes?
So like the variables with the exponents, they're going in order, kind of ordered.
Yeah, so we're ordering them by after alphabetical, which you didn't have to do here. We say let's go top down from the powers of those exponents. So we went 3, 2, power of 0. So we don't care about the coefficient. We didn't care that 91 is bigger than 18 or smaller than 30. We didn't go by exponent. We went purely upon, oh, this is the third power, this is the second power. This is not the power. Let's look at the second one here. Okay? Now, before we start rearranging things, what might we notice? There's like terms, right? There's like terms, okay? Somebody tell me a pair of like terms.
9x, 10x, 3x, x.
Okay? Somebody tell me a pair of like terms. 10x squared and negative 3x squared are a pair of like terms. And what I'm going to do is I'm going to put one underline underneath both of those. I want everybody to put one underline underneath both of those. Okay? Very specific about this, and there's a reason why we'll see this. Okay? It actually ends up being very helpful for us later. Okay? What's the other other two like terms we have here? 9x and negative x. I'm gonna put two underlines underneath these. And we'll see why in a moment. Okay. Now, so I'm gonna combine those like terms, aren't I? Now, if I were to put this in standard form, which one would come first? The x squareds or the x's?
X squared.
The x squared. That's why I put one underline underneath them, because those come first. The two underlines, those come second. So that's the order we're doing here. Thanks for taking that earbud out, buddy. Appreciate it. Okay. So what's 10x squared minus 3x squared? 7x squared. Very good. We don't change the exponent or the variable. We only change the coefficients. We had to make sure they have the same variables and exponents. So we're not going to go changing them now, because we just went to the work of making sure they have the same ones. What's 9x plus negative x, or 9x minus x? Plus 8x. So we have 7x squared plus 8x, and now it's in standard form.
Oh, I thought it was a negative.
It is, yep. So 9x plus minus x.
Oh, yeah, duh, because of the, never mind.
Oh, okay, you thought it was going to be 9, but not like 9 with no x.
No, that was gonna be negative, but then I realized if it's a positive one, it's two.
Okay, questions on that? Okay, so if I were to go through number 3, what would I put one underline underneath? Because I put one underline underneath the first one on number 2. So think about, don't blurt, think about what I would put one underline underneath. What would come first as a reorder? What would come first as a reorder on number 3? Okay, Trinity, what's your thought? Okay, 2a, explain why you would put 2a first. Doesn't have a variable, it has a variable, but doesn't have an exponent of other than 1. Okay, where have we put, what have we put first on the first one? I can't see what you're pointing at when it's that far away. A to the third. We would put that first. Okay. Trinity, why would we put that first? Okay. You got it right. Can anyone else tell me why you put that first? Next, Maria.
Because it has the biggest, exponent.
Yeah, it has the biggest exponent. Very good. That's why we put that first. They're all A's, so don't have to worry about alphabetical. But that one has the biggest exponent. So it's going to go first, because we want it descending, greatest to least. So what would come second? What would I put two underlines underneath? There's no other 8 to the thirds. Levi?
7a squared.
Okay, well, 7a squared. Dylan, is there something else that would also go second? 3a squared. Very good. Thank you for being patient, Levi. Trying to mix it up here, okay? Hannah, what would I put 3 underlines underneath then? To symbolize it's going third. A 2a, very good. Because this still has an A. The 17 doesn't have anything, does it? So how many underlines do we think I'm going to put under that? 4, because it's going fourth. 2, 3, 4. Now, can we kind of see here, after we do this, the order we need to put these in? Yeah, I think this is a really good way to organize, okay, and to make sure we're keeping these straight, okay? So, because and the other thing is this helps us not to forget things. Because sometimes as we start going through this, we might forget something. Dylan, you said wait?
7a squared and 3a squared, which equals together because they're like close.
7a squared and what, you said?
3a squared.
Yeah, we would put them together, yep. That's going to help us remember because they both have 2 underlines. So we're going to go first through and we say, okay, first thing I need to look for one underline. How many things have one underline? 1. Just 1, so I rewrite it. Negative a to the third. We took care of 1 underline. Now we're on the second thing. 2 underlines. How many things have 2 underlines?
2, so you have
So we have to combine them. 7 plus 3, because they're both positive. What's 7 plus 3? 10. So this is 10a squared. We keep the exponent the same.
oh, I need to change that.
Yep. All the times our tendency is to say 10a to the fourth. Nope. We only change the exponent when we multiply. Okay. Dalton, what has 3 underlines?
I put 17, but it's 2a.
2a, right? Yep. 2a we should have 3 underlines. Okay. Go ahead and change it on your notes if you have it then. Okay. So we'll put plus 2A, because that's the only thing with 2 lights. And what's the only thing with 4 lights, Presley? 17, so we'll put that at the end. And now we can take a quick double check, and say, okay, are we in descending order? Yeah, and do we have any repeats, any like terms here? No, okay, so we're done. Questions on that?